Recording. Okay. Recording has started. It is Thursday, October 24th. First period at Washington State School for the Blind. And we are doing geometry this morning. This is lesson 3-7 in our Geometry Connections book. And we have Abby and Angelica and Jessica and Stormy here. It's an all-girls class. Don't be afraid. We'll be nice. All right. So we are on page 128 in print and 128A in Braille. And this particular section is going to talk about perpendicular lines. And before we even start, most likely all of you know what perpendicular means. Yes? What does that mean?
A line that is like 90 degrees.
A line that's at 90 degrees to another line?
Yeah.
Or intersects at 90 degrees? Excellent. So that's what this says up at the very top of this page. Lines that intersect at an angle of 90 degrees are perpendicular lines. And so they have a figure to look at. And we have two lines intersecting at a point. We've learned that long ago. And it says line AB. So AB is going vertically from 12 o'clock to 6 o'clock. They've marked the A directly above and below the arrowheads. And then they have another line, line CD, going from left to right horizontally through 9 o'clock and 3 o'clock. And those two intersect at a point. They're in the middle, and they're not labeling that point. But they did put one of those little square boxes.
Perpendicular lines.
Yeah.
Put one of those square boxes there, didn't they? That indicates that it's perpendicular. C is the point to the left, and D is the point to the right. They don't have any buttons, Abby. They just labeled them with the arrowheads. And then they do the right angle indicator to show that they're perpendicular. So each line's perpendicular. And then they labeled each angle. So the angle on the left, created by the A and C. I wish they would have labeled a vertex point because we could have called out the angle. But anyway, they're labeling that angle 1. And then if we go clockwise, we have angle 2, and then we have angle 3, and then we have angle 4. Now, before we even move on through the rest of the section, we could put our geometry brains on, and everything that we've learned so far, we can think about what's going on in this graphic. We've got two lines intersecting at a point. Do we have adjacent angles happening in this particular graphic?
I think so.
Yeah, we do. Because we have a common vertex and we have a common ray going on all over the place, don't we? Name a pair of adjacent angles.
Would that be 4 and 1?
4 and 1 would be adjacent. Yep. What's another pair?
2 and 3.
2 and 3 would be adjacent. What's another pair? 4 and 3 or 3 and 4. Yep. What's another pair? 1 and 2 or 2 and 1. Exactly. So we have several adjacent angles based upon the definition of adjacent angles having a common vertex and common rays, right?
Yeah.
We have some linear pairs going on here.
Yeah.
Oh, yes. What's that, Abby? The whole thing, Abby says, is linear. Yeah, well, basically, kind of, like, yes, the line AB is a line, right? And so it's creating a linear pairs along it, right? Angle 4 and angle 1, and angle 3 and angle 2 are linear pairs. And then CD is a line, and it's creating linear pairs, angle 1 and angle 2, angle 4 and angle 3. All right, so and a linear pair means that it needs to be adjacent, and then the non-common sides are opposite rays, which create a line, right? We learned that a long time ago, that a line is created by opposite rays. So we're meeting the definitions of linear pairs. Now we know about linear pairs that how many degrees do a linear pair add up to?
They're complementary. They're supplementary.
They're supplementary, right? And supplementary angles add up to what?
180.
180.
So we're like, okay, Yeah, duh. We're going to have 180 degrees here. Well, if angle 2, they put in a little square indicator saying that that's perpendicular, that that's 90 degrees. So angle 2 is 90 degrees. Then what is angle 3?
It's
90 degrees because it's a linear pair with this, and 90 and 90 has to be 180, right? So we're like, okay, we're already applying our skills here, proving some things. We also have the vertical angle theorem going on here if we wanted to discuss that you just learned, right? Yeah. What are your vertical angles in this drawing? Name a vertical angle pair.
1 and 3.
1 and 3, Stormy, excellent. And what's the other pair?
2 and 4.
2 and 4. And what did you learn about vertical angles just like I think yesterday or the day before? Vertical angles are what? Congruent. They're the same. Well, if 2 is 90, what is angle 4? 90. And if 3 is 90 because of the linear pair supplementary deal going on here, what is angle 1? 90. Or angle 1 and angle 2 are a linear pair, aren't they? Yep. So angle 1 would be 90. I mean, you could just go around and use your linear pair supplementary angles rule and get it, but we could apply that vertical angle theorem and also get to the same place. Okay, so just by knowing all that you've learned so far, we pretty much, you're going to discover, have just discussed this entire section off of this one graphic. We're going to discuss the definition of perpendicular lines. Then we're going to discuss the theorem that perpendicular lines form a right angle. And then we're going to discuss that you can you use all the other information that you know to work your way around a drawing to figure out the measurements of other angles. Where the trickery is going to come in here in just a little bit is there's some pretty involved tactiles that have to be read and really carefully finessed our way through to figure out what they're asking. That's the trickery. The information is pretty basic. I mean, perpendicularity means 90 degrees. We get linear pairs. They're all 90 degrees. That's very good, Euclidean geometry, remembering that stuff. Today, what we have to spend our time with is making sure you can make your way around some pretty funky tactiles. Okay?
One more.
Yes. Okay, one question.
I don't know if it's related to math, but when I look at mobility, there's a perpendicular and parallel.
Yes.
I do not understand. What the heck?
So that's perpendicular.
I get confused.
Right.
So these ones, that one's
well, no. So put yourself in the middle.
Here.
No, right in the middle. Okay. So if you're standing right in the middle, facing up, let's say, right?
That one.
Yeah, facing that way. Then perpendicular to you would be immediately to the left or the right.
Oh, that side is
Yes.
perpendicular. That
Yeah. If you were standing in the middle and facing left, yep, then perpendicular would be immediately to your left or your right, immediately up or down.
What does it mean when it's parallel?
Parallel means, and we haven't got to parallel lines yet,
Okay,
but parallel means that it's like right in front of you but won't touch you.
Okay.
So here, so you're standing right in front of me, put your hand out, and I give you this pin right in this orientation just like that, going back and forth, right? This pin is parallel to you.
If I'm standing here,
that's parallel to you.
Okay,
But Abby, hold on. So hold your hand up. If I turn the pin like this and point it at you, it's perpendicular to you.
Okay.
Does that help?
Yep.
Awesome. Who knew geometry would turn into an orientation and mobility lesson? It is a useful mathematics now, isn't it? Now you can apply it to your own M skills, which is very important. You're right. Right. Well, and also think about orientation and mobility. They use the clock, don't they? 12 o'clock, 6 o'clock, 3 o'clock, 9 o'clock. So those are all, from 12 to 6, that's perpendicular to 9 and 3. Yeah, see that? Yeah.
And they're all multiples of 3. Ha ha ha.
They are. Yeah. And so then they talk about quarters too. You do fractions, right? Quarters and halves, because you do quarter turns and half turns, right?
Yeah.
Well, if you're facing, let's say, north, and you do a quarter turn, now you're perpendicular to where you were. If you do a half turn, now you're 180 degrees from where you were. Yeah. Okay. You also talk degrees in orientation and mobility too, don't you? Yeah. 90. Yeah. So 90 degrees is perpendicular. That's your right angle. And 180 is a straight angle, right? Is a line. Yeah. Good.
My
Excellent.
favorite one's 360 because I get to spin around.
360, you get to spin around. That's right.
Yeah,
about turn. That's 180. 180 turn. All right. So, they on the next Braille page, they discuss the square symbol where the two lines intersect, which we've already discussed. That indicates perpendicularity. And then it forms 4 right angles. We already figured that out, didn't we? And it also has a bunch of adjacent angles that are supplementary, which then form linear pairs. So we already discussed everything in the next 2 paragraphs. The next page, C128, has the official definition of perpendicular lines. All right, so in words it says perpendicular lines are lines that intersect to form a right angle. So we just put that in official geometry language, and then they have a nice graphic again that's very similar to the last graphic, and they have the little symbol, and that's right. So your little symbol is what, EDP?
Yeah.
Yeah, EDP.
What's with the upside down T anyway?
The upside down T. That is the print symbol for being perpendicular.
Oh,
So yeah, because it looks like perpendicular lines, doesn't it? Mm-hmm. So in print, Angelica was like, "What's with the upside down T?" And it shows that M is perpendicular to N. Line M is perpendicular to line N. So at the very bottom, oh, turn your page, sweetie. Yeah, there you go. The very bottom of your drawing, you have 2 lines that are perpendicular to each other. You got the little square box there showing that they're perpendicular and creating right angles. And then in symbols, down underneath the drawing, it says line M is perpendicular to line N.
That kind of looks like a Greek
symbol. Yeah. And perpendicular in Braille is EDP, and in print it's an upside down T because it's showing it perpendicular to the top part of T. Okay? All right, turn the page, Braillers. Print users, you're at the bottom right corner of page 128. There's another tactile. Now they take this drawing. These are still, even though they're at angles, they're still perpendicular to each other, yes. And this time they even have some points, as Abby likes to say, buttons. They have little button points, yeah. And if we start at about 8 o'clock, that's point A. And then we go clockwise, we have point C. Then we have point B at about 2 o'clock. So that is, that's your line AB running from about 8 o'clock to 2 o'clock. Oops, I got my drawing got a little off here. And then the next point would be point D, and you have then line CD running from about 11 o'clock to 5 o'clock or so. Yeah. And then there's a little square in the middle there at the vertex, and the vertex is labeled E, just below.
Oh, I
See that? Okay. So we know a bunch of stuff going on with this drawing. There's rays and linear pairs and adjacent angles and all sorts of stuff. We know that they're 90, 90, 90 all the way around. The paragraph of information says, because rays and segments are parts of lines, these two can be perpendicular. So ray EC is perpendicular to line AB. That's what they're saying. Okay. Ray ED is perpendicular to line AB. Ray EA is perpendicular to line CD, and ray EB is perpendicular to line CD. So you can also say, you don't have to have a line going all the way through. You can have just a ray going, stopping to a line and being perpendicular. And that's important because later we're going to need to use this to prove that a square is a square or a rectangle is a rectangle because of this perpendicularity of segments. It says for rays or segments to be perpendicular, they must be part of perpendicular lines and they must intersect. In the figure at the right, EC is perpendicular to EA and CD is perpendicular to AB. All right? So that just reminds you that they can be rays. Then I like the next, let's see, we got to turn. Let's see, what does it say? I know, I want to see what this says. Yeah. All right, so I am looking at 129B. Yeah, I think this one. Oh, wait a minute. Hold on, what happened? I lost the page.
What happened to A?
That A. Ooh, we lost a page. I am missing a page in my book.
No way.
Yeah. You guys have a page that I don't have.
Weird.
Weird, that's right.
So now that I can teach the class.
I know, this is a bummer. All right, well, I will use my print version to explain what's going on. What's really cool now is this whole proof process, right?
What page are you on?
We're on 129, and in Braille it's straight up 129. I don't have straight up 129. That's missing.
You might want to complain.
This is a newer volume that we purchased this summer, and they missed a page there. Or it could be later on. It might have got filed. I'll find 129 in volume 60. All right. Well, I can describe it from my print version, okay?
Yeah.
All right. So what you have here is you have a figure where it says line L is perpendicular to line M. And then they're going to do a proof that's going to help us create theorem 3-8. And we sort of already talked about this proof at the very beginning of the lesson when we talked about all the things that we know so far. So first we take a look at the tactile and make sure that we really make ourselves familiar with the drawing. We have line M going from 12 o'clock to 6 o'clock and line L going from 3 o'clock to 9 o'clock. And then they've labeled the angles 1, 2, 3, and 4 starting in the top left and going clockwise. And then they put a little perpendicular square indicator with angle 1 to say that, okay, M is perpendicular to L. Plus they gave it to you. They said L is perpendicular to M in symbols. Okay? So the one thing that I don't like that they didn't start out with, which is really a good habit, and we'll practice this later, is to state the givens. And so you'd want to, your first statement you'd want to say is line L is perpendicular to line M, and you would say given, because it was given by the directions and the drawing. Then they state, so if you look at number 1, they're taking you through a formalized proof process. So they number the things that are going on and the reasons why. So they say angle 1 is a right angle by definition of perpendicular lines. Okay? Because that says perpendicular lines are lines that intersect to form a right angle, right? And so they're saying that because you're given that line M and line L are perpendicular, then you get to say that angle 1 is a right angle. Angle 1 is congruent to angle 3 because of the vertical angles are congruent theorem, right? And they state that. Down below, they're writing all the proofs out. So read down below, Abby. So number 2 says angle 1 is congruent to angle 3 because of vertical angles are congruent. So it's down below your drawing. Are you in the right spot? Are you lost? Back up one page. Oh, you're missing letter A too.
Am I? No, I'm not. It's right here.
You're missing regular to 129 straight up.
I'm
Are you?
Sure.
No. Oh, there it is. Okay, you need to be there. Okay.
Oh, okay.
All right. Do you have 129 straight up, Stormy?
Yeah.
Okay. All right. So then below your drawing it says number 3. Angle 1 and angle 4 form a linear pair. And this is by definition of linear pairs. Right?
That's obvious.
Yep. And then angle 1 and angle 4 are supplementary because linear pairs are supplementary. Jessica said that earlier. Angle 4 is a right angle because the measure of angle 4 plus 90 would equal 180. Therefore, the measure of angle 4 is 90. And then it says angle 4 is congruent to angle 2 because the vertical angles are congruent. So now we have proved that every one of those angles is 90 degrees based upon what we know from all our previous lessons and the one we just learned with definition of perpendicular lines. So by doing that proof, then it creates theorem 3-8, which is on the next page. Now I actually do have that page. So turn to page, 2 pages. So 129B, and it has a model in this one, a tactile with 2 perpendicular lines. And then it has, the lines are labeled little a and little b. And then they have 4 little right angle indicators going throughout the entire drawing, creating
You were only supposed to turn one page.
Creating a square, huh? Yeah, just one page. There you go, Jessica. Good. And then top left is angle 1. Then going clockwise, you have angle 2, angle 3, and angle 4. All right. So that's your model for this theorem. And the theorem states up at the top, if 2 lines are perpendicular, then they form 4 right angles. Always, always, always. So, of course, Jessica said, this is obvious, right? Because we already figured that out when we just took a look at our 2 perpendicular lines at the beginning of the lesson, and we discussed all the stuff that we knew, and we figured out, all of them are going to be 90 degrees. So, again, we got to officially state it, though. We're Euclidean geometrists. We officially state it because this is going to be super important later to be able to prove something like a shape that's being made. Okay? And then in symbols down at the bottom below your drawing, it shows you that angle A is perpendicular. They just do A, letter A, and then EDP, B. It just says A is perpendicular to B. And then they do the measure of each angle. So they have the M and then the angle symbol, ED, and then OW. 1 equals 90, and then they just go through and describe, measure of angle 2 equals 90, measure of angle 3 equals 90, measure of angle 4 equals 90.
So measures 1, 2, 3, 4 all equal 90.
Correct. And what is 90, 90, 90, and 90 added up all together? 360, because if we started at 1 and went all the way around and got back to 1 again, we did an about face, right? Not an about face. We did a spin. We did a twirl, right? We did a Jessica twirl. Stormy, what was your question?
Oh, I said
No.
go soon.
Oh, you have to go soon. Yeah, 5 minutes. Yeah, thank you. All right. So let's turn the page. This is where we got to spend a little bit of time. This graphic is very involved and busy. And you got to kind of section it out and think of it in terms of just 2 lines at a time, really. Otherwise, if you try to make sense of all the lines going on, even to look at it is super busy. All right? So it says in the figure, OP is perpendicular to MN. That's what it says up at the top, one of the first statements. So before we even move on, let's find OP, line OP, and line MN, and just focus on those 2 lines.
Line M.
So M is at about, 11 or 10 o'clock? Yeah. And then it goes down to about 5
I
o'clock.
don't see an N
N is way down, way down. Did you find it? Okay.
Yeah.
So that's N, MN. Okay, so just focus on that line, kind of go back and forth on that line and go, all right, I got that line nailed. It's got a couple of button points for me. It doesn't have a button point at N because it intersects with another line. If you go back to the vertex, there is a little square indicator, all right? And that's indicating 90 degrees to OP. Now, O is down at about 7 o'clock. Okay, O is at about 7 o'clock. And that then stretches up. There's a button there at O. And that stretches up diagonally through about 1 o'clock. Right? Okay. And that's going through P at an intersection point up there. Now, if you just focus on those two lines right now, only focus on those two lines and think about what's going on, you have two perpendicular lines, so you're creating 90 degrees all the way around the middle. Now, the middle point, the intersection of those two lines, directly below it, they're labeling it R.
My initials.
Yeah. So we could, you have find it? Okay. So if you go back to M, and then you come back down to the vertex point R, and you go back over to the O point, right? You go back and forth along those two rays, you have a right angle, correct?
Yep.
Which then if you feel inside of that right angle, notice that they've marked angle 1, angle 2, and there's a ray going through the middle of it. There's two angles that have created that are part of that right angle. There's two adjacent angles, 1 and 2 are adjacent, that have made that angle. Put your brain on and think to yourself, well, if that's a right angle, do you know the measurement of angle 1 and angle 2?
Yes.
Yeah, what are they?
90.
What would angle?
90.
Oh, well, they be together, they would be 90. What would they be separately? Based upon what's going on here.
45.
45s. Yeah, it's a bisector, isn't it? Yep. Yeah, but we'll get there. So go back to R, your intersection point. Then go back up to M. Now go back down to R and then up to P at the 1 o'clock position. There's a 90 degree angle, right? MRP. Angle MRP is 90 degrees. Phew. Okay. Go back to R. We're back at R.
That little V.
And then go back up to P and back to R again. Feel that ray. So we have PR. Now go to N, Abby says, right? And we've created, there's our other 90 degree angle, correct?
Yeah.
Now if you feel on the interior of that angle, angle PRN, we have two more angles labeled. 3 and, what are we, 4 and 5? Or 5 and 6.
5 and 6.
5 and 6. My Braille dyslexia always likes to turn around those 6s and make them 4. All right, 5 and 6. Okay, and that's going to be, what are the measures of those two angles most likely going to be?
Yeah.
45 and 45, right?
Yeah.
Because they got to create the 90.
Why they have
Okay, now we're going to talk about that later. I told you to stay away from that line. Get off that line.
Darn it.
I was trying to figure out NP, and I said,
So am I.
you can't be over there yet. You got to say, all right, I got to ignore that right now because I'm focusing on what it said to me was OP and MN. We don't want to be thinking about NP and QP and all that crud. Okay, go back to R. Now, go down to the 5 o'clock position to N, right? Ray RN. Go back to R, and then go to the, 7, 8 o'clock position at O, RO. Okay, so we have angle ORN or NRO. That's a 90 degree angle, right?
Mm-hmm.
Okay. Phew. All right, so we made our way around all the stuff that had to do with OP and MN. Now we get to go look at the rest of the information, and it says up top that line NP is perpendicular to line QS. Now we go back to our drawing and find those 2 lines, and we ignore the other 2 lines for right now because we want to focus on those 2 lines. And I'm going to stop for just a second because I think Stormy needs to leave.
Yeah.
Okay. All right, Stormy. So what I was going to do, you're not going to be here tomorrow. I'll record tomorrow's lesson also and email it to you.
Okay.
All right.
I'm
But
trying to get on, but
we're gonna be in this volume 10, and we're gonna be finishing up 3-7. So I'll send you the link to today's YouTube and a link to tomorrow's YouTube, and you can refresh your brain on 3-7. And then I'm going to assign number 1 through 7 for homework.
I'm not
Okay.
gonna be here tomorrow either.
okay.
So page 131 to 132, I'm going to assign number 1 through 7. Okay?
Okay.
All right, we'll see you on Monday, okay? But look for an email from me, and there'll be a couple of links to YouTube for you to watch, and you can take volume 10 home and follow along.
Okay.
Okay, have a good day.
You too.
All right, so the rest of us, here we are back at our drawing, right? And we're looking at what are we looking at? PN or NP, right? NP. So P was back up at that kind of 1 o'clock position, but now we're going directly down below it through N. And so that's a line NP or PN. We can say our lines in different orders, right? And then it also is talking about a line that's perpendicular, QS. All right, QS. Now, this is where they messed up, and they did not label your S point on your braille.
Oh, that's
I know. So the S point is right directly below the little square box where those 2 lines intersect on the right-hand side, and then you go immediately to the left through Q on the left-hand side at about the 9 o'clock position. Okay, so that line QS is perpendicular to PN, and it shows the little square indicator there at the intersection point, and then it labels a couple of angles, angle 8 and angle 3. And we know all those angles would be how many degrees?
Angle 8.
Angle 8. How many degrees would be angle 8? If 90, right? And then the angle across from it, if it was labeled, it's supposed to be labeled angle 4, but they didn't. They messed up. That would be 90. And then the angle next to the S point, that would be 90, correct? Okay. And then because that line is perpendicular to each and it goes directly through the vertex of our other 2 lines, it's a bisector. You're going to learn that later, that that's a bisector of those 90-degree angles. Yeah, so the angle that goes, the line that goes from 3 o'clock to 9 o'clock, this line here, is this your vertex point here. It's bisecting that angle and that angle, creating angle 1 and 2 and 3 or 1 and 2 and 5 and 6. So we know for sure that those are 90-degree or 9-degree angles, and they're being bisected, so they're 45 each. Okay, all right. So I'm going to stop there because we only have a few minutes, and to launch into the rest of the information gets pretty involved, and we'll pick up tomorrow at this particular section and review this on page 129, and then tomorrow we'll record the rest of this section so that Stormy and Bryant and any others that want to listen to it.
I won't be here.
Angelica wants to listen to it. Carly likes to get links to these, and some of the afternoon kids, they can listen to this section and follow along. All right, so I'm going to stop the recording for today, and we'll pick it up tomorrow.